All right, the next tool in understanding about what happened on the Earth before humans were here is fossils. And fossils are probably the most powerful tool that scientists can use to understand about what's gone on Earth before we were here, before the time of humans. And so how they tell us, there's a couple of things that they can tell us. But before I get into that, I want to talk about fossils and how they are rare. There is kind of a misconception that people think that there are lots of fossils, that we have fossils of every creature that's ever lived. But we need to understand that that's not true. And here's why. It's very difficult, the fossil process. An animal, when it dies, it's very likely that all of its soft tissue, like eyes and the heart and the skin, is going to decay away. Bacteria is going to eat that. Scavengers are going to eat that. I mean, all you have to do is think about seeing a dead deer on the side of the road, and it's never alone. There's usually ravens and sometimes an eagle there um, eating it. And so it takes a very specific situation for a creature to become fossilized. And some scientists estimate that about 1 out of every 1 billion bones becomes fossilized. Let's try to help you understand that concept. If we take the entire United States, there's 300 million people in the United States. There's 206 bones in the human body. So if every person in the United States died, 1 in a billion bones becoming a fossil means that there would be about 50 bones fossilized in the United States, in the entire United States, which means that we're probably not going to have a fossil of every creature that's ever lived. And second, it's really hard to find them. Now, fossils can help us interpret and understand what went on before us. An example would be if we look back in rock layers, we get to a point where we find only marine fossils. It's shellfish and fish and things that live in the ocean. And then, therefore, we can interpret that at that particular point in time, all life existed in the ocean. So that's how fossils can help us learn about the past, and that's why they're so rare. The other thing that fossils show us, as we look at the fossil record of all the fossils that we do have, and even though we don't have every fossil, we still have enough to show that throughout time, what's happened with life on this planet. And what we found out is that diversity in life came very late. There was a long period of time on this planet, something like 80% of the Earth's time, where there really wasn't much anything on this planet except some bacteria. And then there was this huge explosion of diversity in the last 20%, the most recent time on Earth. So complexity developed over that time. You can see in this diagram, this picture here, we've got shellfish, and then in the lower right-hand corner, we have this thing called a trilobite, which is kind of like a crab, and then we've got fish, and then we've got more complex creatures, the Tyrannosaurus rex. So complexity happened over time. We started with bacteria, we went to algae, and then we went to these really complex creatures. I'm kind of joking here. Jellyfish, which don't even have a brain or a stomach, and then diversity began from there. So we had fish that had a vertebrae, and then amphibians, reptiles, mammals, and this huge development of creatures. But it happened over time. Everything didn't just exist at the same time, all these different creatures. Now, how does a fossil form? It happens, of course, the creature has to die, and second, we have to have quick burial. So you gotta have a landslide, you gotta have a mud flow, ash deposits, it's gotta be in a stream, a river, or near the ocean where it gets covered up with sediments very quickly to prevent those scavengers from eating it away. And then one of two things happens. It either produces a cast or a mold, and we can see this in the diagram here in the lower left-hand corner of this trilobite. So we have the cast and the mold. One is an impression, and one is like stepping in the mud and leaving a footprint, and the other is what made the footprint. And so those are the cast and the mold. And then the other thing that can happen is that, and a lot of people don't realize this, is that bone or bones sit in the ground, and groundwater seeps in there with minerals in it, and it eats away the bone, and replaces that, a copy of it, with minerals, like quartz, for example. It's called permineralization. And that's actually what we end up finding a lot of times, is these bones that are not actually bones anymore. One of the reasons why fossils are really cool to talk about in Montana, other than the fact that they help us understand about the past, is that Montana has a tremendous wealth of dinosaur fossils. There are more fossils of dinosaurs in the state of Montana than in any other state in the United States. And it just happened that the geology here in Montana, the environment at the time, was a great place for dinosaurs to be. So there's lots of dinosaur fossils here. A few notable ones. The Tyrannosaurus rex. The first complete Tyrannosaurus rex was found in Montana in 1988. And actually, if you take all of the places in the entire world where Tyrannosaurus rex fossils have been found, there's about 30. And 21 of those are in Montana. The next one here is the Maiasaura. Now, Maiasaura means good mother lizard. And the reason why it gets that name, and the reason why Maiasaura is our state fossil, is that it was the first place in North America where we found a dinosaur nest. And this actually changed the way that paleontologists thought about dinosaurs, because at the time, they thought they were these cold-blooded animals like lizards. But finding this nest, finding adults and juvenile fossils in this nest, let them know that dinosaurs cared for their young, like birds, which are warm-blooded animals. Totally changed the way that scientists thought about dinosaurs from 1978, that discovery, forward.